Now in this video, I've got the NPN 2N2222 transistor amplifier. On the collector side, I've got a 500 ohm resistor and 5 volts across it. And on the emitter, I've got a 100 ohm resistor and I've got 1 volt across it. So the collector current equals 10 milliamps. Now on the back of the transistor, I've got resistor R1, which is 15.8 kilo ohms, and resistor R2, which is 3.2 kilo ohms. On the input, I've got a 1 volt peak-to-peak sinusoidal with a frequency of 4 kilohertz in series with a 22 microfarad capacitor and a 10 millihenry inductor. So you can see here that I have the sinusoidal input. Now, over here is the impedance the input sees as it goes into the base of the transistor. The frequency is 4 kilohertz, which gives me an inductive reactance of 251 ohms. Now, what I have to find is which voltage will be amplified. The input voltage that will be amplified is not this one. It's not the 1 volt peak to peak. The input voltage which will be amplified will be the voltage that will be falling across my 3.2 k ohm resistor. The voltage across my resistor, that will be the voltage that will be amplified out here. So what I have to do now is I have to find the current that is going through this circuit so I can find the voltage that will be going through my 2.3 k ohm resistance right here. Now, where did I get this from? This 2.3 kilo ohms is found by the parallel combination of my 15.8 k ohm resistor and my 3.2 k ohm resistor and another resistance called ZB, which is seen from the base of the transistor down to ground. When I take the parallel combination of those, I end up with 2.3 kilo ohms. Now to find my impedance, I must first find the total resistance of my XL and my 2.3 k ohm resistor. Now my total resistance will be Z total. Now that total is what the input sees as it goes into the transistor. That will be 251 ohms squared plus 2.3 k ohms squared. And that will give me a Z total of 2,313 ohms. Now I use my 2,313 ohms and I find my input current. So my input current, IN, equals my 1 volt peak to peak divided by my 2,313 ohms and that gives me a current of 432.3 microamps. Now what I do is I take that number and I multiply it by my 2.3 k ohms. And I get a voltage of 994 millivolts. So my input current, my input voltage is 994 millivolts. Now that voltage will be the voltage that will be amplified out here. via equals. Now my voltage gain will be 500 ohms divided by 100 ohms plus 2.6 ohms. Now, where did I get my 2.6 ohms from? That comes from a thermal voltage. Thermal voltage RE is my 2.6 ohms, and I take my thermal voltage of 26 millivolts and I divide that by my 10 milliamp current, and I end up with a resistance of 2.6 ohms. Which gives me a voltage gain of 4.87 volts. 4.87. It's not volts. It's just 4.87. Now I take my 4.87 and I multiply it by my 994 millivolts. .87 times 994 millivolts .87 times 994 millivolts. And that will give me an output voltage of 4.84 volts. Now, if you increase the frequency, you will get more voltage across the inductor and a smaller voltage on the input, which also means that you will get a smaller voltage on the output. Now the